All right, let's jump right in. In this explainer, we're unraveling a pretty profound mystery about how the human brain actually develops, and more importantly, how our society completely misreads it. Let me start you off with a baffling real-life story. Recently in Nice, France, there was this 4-year-old boy who essentially turned his entire school system upside down. He was the youngest kid in kindergarten. He just transferred from a nursery school where he was, frankly, absolutely miserable. He couldn't connect with his classmates, couldn't follow the curriculum. But here's the thing. The problem was never the boy's brain. The problem was the ruler they were using to measure it. Can you imagine a teacher saying this? He is bad and can't do anything. That's exactly what his former nursery teacher would tell him. She spent entire mornings standing in front of the whole class, publicly shaming this kid, declaring that he was quote-unquote bad. And why? Because this 4-year-old struggled to trace those simple, overly simplistic dotted lines on a piece of paper. He just didn't have the specific fine motor ability to connect those dots at that precise moment in his life. But to that teacher, failing this one standardized milestone meant he was failing at literally everything. The system viewed his development as this straight, flat line, and because he stumbled on one single step, they branded him a failure. But the contrast here is just staggering. When his parents finally moved him to a new kindergarten, his new teachers literally had to help him relearn how to feel safe in a classroom. They just started talking to him about dinosaurs, letting him explore at his own pace. And as he opened up, they made a shocking discovery. He had been hiding these immense cognitive abilities. By early 2025, they realized this same boy, the one who supposedly couldn't do anything, had already mastered complex grammar. I mean, we're talking about the notoriously difficult subjunctive tense. His handwriting was absolutely flawless, far better than the older kids. In fact, they eventually found him out in the schoolyard, casually correcting the reading mistakes of first graders. So what's actually happening here? Well, this boy wasn't broken. He's a textbook example of what we call asynchronous development. It's a reality we see all the time in gifted or twice exceptional, often called 2E, children. It basically means your intellectual, physical, and emotional growth, they don't all happen at the exact same time. The mind actually develops at staggered intervals. You can literally have the complex grammar skills of a 10-year-old, but the fine motor, dot tracing skills of a toddler. But as we just saw, our educational and bureaucratic systems completely misread these kids. And that brings us to a much larger societal issue, which is the sheer blindness of our linear institutions. When bureaucratic systems or, school evaluators look at a high-dimensional, highly complex mind, they try to force it into this rigid, flat, one-dimensional template. They operate under this entirely false assumption that your cognitive networks, your skills, your personal progress, it all just has to mature perfectly in sync, along a straight line. If you're 4, you do 4-year-old things. And if you're out of sync, well, then you're a problem. So why do our systems miss the mark so consistently? First off, they assume perfectly synchronized growth. Second, because they operate like simple one-dimensional processors, they literally lack the hardware to map out a brain that's developing asynchronously. They just can't see the complexity. Third, when they spot a circuit that is out of sync with their standard timeline, they immediately pathologize it. They label it a deficiency, often throwing around clinical diagnoses like ADHD, instead of recognizing it as staggered high performance. And finally, they refuse to adapt. Instead of leveraging these incredibly specialized neural circuits, they just enforce low bandwidth compliance. Follow in line, or else. But what if I told you that hard science has just definitively proven that these institutions have it entirely backwards? Let's step away from the human story for just a second and look at the neurobiology. Because recent breakthroughs in neural network mapping have totally dismantled this idea of linear brain growth. Researchers are now finding that neural networks in complex architectures do not mature in a neat, uniform sequence at all. They're actually staggered. To really wrap our heads around this, we need to look at a very specific number, 302. That is the exact number of neurons in a tiny little roundworm known as C. elegans. Now, you might be wondering, why on earth do we care about a microscopic worm? Well, because out of all the animals on Earth, C. elegans is the only one that has a fully mapped neural connectome. Scientists literally know every single one of its 302 neurons and all 7,000 of its synaptic connections. It's essentially the blueprint. It holds the key to understanding the very foundation of how neural development works. So, researchers from the Guangdong Institute of Intelligent Science and Technology and Beijing Normal University took this worm's brain data and ran it through something called the Big Clam algorithm. And this is a brilliant example of technology uncovering biological truths. Big Clam basically identifies which neurons belong to the same functional communities based on how strong their connections are. By tracking where the synapses were heaviest, scientists were able to watch, step by step, how these specific neural communities actually form.
And the findings? Absolutely profound. Neural circuits do not develop simultaneously. No way. They sequence out in a staggered, asynchronous, 3D-like structure. Check this out. At larval stage 1, the worm only develops neural communities for basic survival stuff, like regulating its pharynx. It isn't until larval stage 4 that the circuits for complex behaviors, like sleep-like quiescence, start to show up. And the functional circuits for movement and egg-laying, those don't fully wire up until the adult stage. The nervous system is building these functional communities in a very staggered sequence, not all at once.
Dr. He Lu, who was the corresponding author of the study, synthesized it perfectly with this quote. He points out that if this sequential development applies to humans, and it does, it completely changes how we view learning. If we try to force a behavior way too early, like advanced math, the neural community simply isn't there yet. Now connect that right back to our 4-year-old boy in France. His language and grammar circuits, firing at a genius level. But his simple, fine motor dot tracing circuits, they were just on a totally different, perfectly normal developmental timeline. The linear school system literally punished him for biology. So if our schools and our institutions are trapped using these flat, one-dimensional rulers to measure three-dimensional brains, how do we fix it? We clearly need better tools to see the unseen. And that transitions us perfectly into how artificial intelligence is becoming the brand new lens to see these hidden cognitive realities that our human institutions are completely blind to.
Let's look at a groundbreaking study out of Stanford University that proves exactly how much nuance we are currently missing. Researchers wanted to see if they could spot early signs of mental health risks in kids, specifically anxiety and depression, long before a traditional human diagnosis would catch it. So they took over 200 children between the ages of 9 and 13, recorded them talking about stressful events in their lives, and then fed that audio into 4 different AI language models.
The results of this comparison will blow your mind. Traditionally, figuring out psychological risk in kids means building these thick, time-consuming expert dossiers or running expensive blood tests to look at cortisol levels or literally measuring telomere lengths on chromosomes. But the AI speech analysis, it outperformed all of those methods combined. And it didn't do it by looking at biological markers. It did it just by analyzing fast, super cheap audio of the children speaking. More specifically, it analyzed their use of tiny little connecting words.
Fascinatingly, it turns out that how a child speaks is a much more powerful predictor of future depression than what they are actually saying. The AI detected that a really high use of tiny connecting words, prepositions, and conjunctions like and, but, and to was a massive early risk marker. Now, of course, the content matters too. Narratives that involved physical violence or severe social exclusion, like feeling the whole school is turning against you, those definitely elevated the danger level. Conversely, children who spontaneously brought up therapy, sports, or hobbies showed really clear resilience. These are tiny, high-dimensional data points hiding right in plain sight, totally invisible to a standard evaluation. Stanford psychology professor Ian Gottlieb noted the revolutionary potential here. Speech is incredibly cheap to analyze, and it's easy to scale. If you can catch the subtle linguistic markers of anxiety and depression during those really crucial pre-adolescent years, well before a full-blown crisis hits, you can literally change a child's life. Think about it. An everyday smartphone could eventually serve as an early warning system. It could use AI to map out the complex, asynchronous emotional development of a child, something a busy teacher or standardized test would miss entirely. So, let's pull all of this together. The core takeaway from our deep dive today really boils down to a tale of 2 realities. The old reality relies on one-dimensional linear rulers. It's a system that forces 4-year-olds to trace dotted lines and then actively shames them when their naturally developing neural circuits don't match a bureaucrat's checklist. But the new reality, it's about recognizing 3D asynchronous networks. From the mapped connectome of a roundworm to AI models analyzing the subtle conjunctions in a kid's speech, the science is screaming at us. Minds develop at staggered, highly specialized intervals. We finally have the biological proof. We have the technological tools to actually see the 3D mind in action. We can catch vulnerabilities early, and we can cultivate extraordinary gifts that would otherwise be crushed by a standardized system. But all of this leaves us with one incredibly urgent question. As the science leaps forward, are our schools, our bureaucracies, and our institutions finally ready to abandon the linear ruler? Thanks for watching, and keep questioning the ruler.